Hi everyone, today I'm going to walk you through some of the most important aspects of my final project. So for my final project, I decided to enhance a model that I found in NetLogo's model library. It's a climate change model. As you can see, the model only has one surface type. It also has only one albedo value. The albedo value is the value that controls how much light gets reflected when it hits the surface. As you can see, also there's no water, there's no ice, so there's only one surface type. So the modifications that I decided to implement for this model were first I decided to add 4 different land types. So I added vegetation that's going to be green, I added soil that's going to be brown, I added water that's going to be blue, and I added ice that's going to be white. I also added 4 sliders so the albedo values for each land type could be controlled. I also added sliders to increase and decrease the amount of vegetation and ice in the model. I also added code so that when rays hit the different land types, they interact based on the albedo of the land type they're hitting. So, for example, if they hit the vegetation, they're going to interact based on the vegetation albedo. If they hit the soil, they're going to interact based on the soil albedo, and so on. I also added a functionality so that ice would start melting after the global temperature has reached 25 degrees Celsius or higher. So once it hits that temperature, ice is going to start melting at a rate of 0.0001. I also modify the code to ensure that the rays hit all land types, because in the original model they would only hit one specific spot of the land, and I didn't want that because I wanted the rays to hit all land types. Some of the assumptions that I made for this model were that, first of all, the model only represents daytime. There's no day and night, uh, like in real life. Also, rain and other weather phenomena like hurricanes, storms are not contemplated in the model. There are no seasons as the Earth orbits the sun, so there's no summer, no winter. It's always the same season. There's no human interactions in the model, and the burning of fossil fuels is not accounted for either. So let me show you the model real quick. As you can see, once I start the model, I can, increase, decrease the amount of vegetation. Same with the ice. I can play around with the albedo values, um, and it will show you the global temperature as, the ticks run. Um, so some of the verifications and validations that I did for this model, the first test that I ran to validate and verify my model was to set um, the new model with this 4 albedo values, and the expected result was that all the rays that hit the vegetation and water should be absorbed, while the rays that hit the soil and ice should be reflected because they have a albedo value of 1. So as you can see in the screenshot, all the rays that hit the soil and the ice got reflected because they had an albedo value of 1, while the ones that hit the vegetation and water got absorbed because they have an albedo value of 0. Test number 2 was to set the new model with this albedo values and only 2 surface types, and the old model with a surface albedo of 0.60. The expected result was that the global temperature of the new models should go up faster since water absorbs more energy than the regular surface albedo. As you can see in the new model, after 1,000 ticks, the temperature was higher than the temperature in the original model after 1,000 ticks because of the water. And the third test was to set this 4 albedo values and set this albedo value for the old model. And the expected result was that the temperature in the new model should rise faster since all these albedo values are pretty low. Ice is the only one that has a high one, but remember that ice will start melting also as temperature goes higher. Again, you can see that in the new model, after 1,500 ticks, the temperature was 30.9, which was higher than the temperature in the original model after, again, 1,500 ticks. And you could also see that the ice started melting because the ice started around here. This was where it started and started melting. I also tested my model against real data. So I found this table that has the mean average temperature for the world. for for the last couple of decades, and I executed my model. And after some fine tuning, I was able to get real close to those results. Um, the biggest difference was 1.37. So every time a model was pretty close to um, the results in in the original table. So overall, did a pretty good job, even though it can always be improved. But that's all. Thank you.